Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X published on August 13th, 2025, which was just 2 days ago. The standout contribution is a clear blueprint of faster, resource-aware, large language model designs that trade quadratic attention cost for speed, without giving up much capability. The paper is titled, Speed Always Wins, a survey on efficient architectures for large language models. And as we'll see later, the implications for deployment and training are quite significant. In short, the survey maps 7 families spanning linear and sparse sequence modeling, efficient full attention, sparse mixture of experts, hybrids, diffusion models, and cross-modal applications. Building on that, the tweets praise the survey as comprehensive and beautiful, highlighting cheaper inference, longer context, and near real-time models across linear, sparse, attention, and hybrid approaches. Engagement looks solid, with one post around 500 likes. Alright, this overview diagram maps the landscape from input tokens to output tokens. The large left block groups efficient sequence modeling, splitting into linear methods, sparse sequence modeling, and efficient full attention. Building on that, the horizontal strip below highlights sparse mixture of experts with routing, expert design, and conversion. Moving right, the next column shows hybrid architectures across interlayer and intralayer mixes. Then, diffusion language models cover non-autoregressive paths and bridges to autoregressive modes. Finally, the green column summarizes extensions to vision, audio, and multimodality. Next, this figure illustrates why long sequences explode costs across common workflows. The top row shows retrieval augmented generation, where a short system prompt is followed by a very long document, then a brief user query. Below that, the agentic flow alternates user turns, generations, and tool calls, stretching length through many steps. The reasoning row interleaves thinking segments with generations. Finally, the multimodal row stacks long text, image, video, and audio streams before a user turn. Continuing from the long context patterns, this taxonomy pulls everything together, showing where each efficiency idea fits in the broader ecosystem. The left spine groups 5 themes, and the colored branches enumerate concrete subfamilies and examples. Focus first on the 3 sequence modeling trunks, which split into linear, sparse, and efficient full attention, each with subnodes like state space models, dynamic sparsity, and quantized attention. Then the next blocks cover sparse mixture of experts, hybrids that interleave components, diffusion language models, and finally, extensions to vision, audio, and multimodality. Okay, this table compares linear sequence modeling families by 2 axes, how the model writes to memory using gates, and what optimization objective it minimizes. To orient you, the rows group methods into softmax attention, sliding windows, linear attention, linear recurrent networks, state space models, and test time training. Building on that, each row lists the specific memory update rule, then the loss, showing a progression from data-independent decay to data-dependent gating, and from L1 style to L2 style objectives. Wrapping up, 2 takeaways stand out. Speed is the real enabler, with linear sequence models, sparse patterns, and quantized attention cutting costs for long context and faster inference, and hybrids plus sparse mixture of experts recovering accuracy while shrinking key value cache memory. State space models, meaning sequence processors with explicit hidden dynamics, exemplify this balance. I am Alex. Thanks for listening.